We're surrounded by all these amazing machines that move, but a lot of them work without any fire or explosions or fuel. Nope, they run on pure electricity. And they're honestly one of the most important inventions in history. We're talking, of course, about the electric motor.
But that kind of brings up a really fascinating question, right? How in the world do you get from a current flowing through a wire to a car actually driving down the road? How does something as invisible as electricity create powerful physical motion? Well, that's the mystery we're going to unpack today.
And look, it is really hard to overstate what a big deal this is. The electric motor, it isn't just another invention. It's the silent, powerful workhorse that runs pretty much the entire modern world. Just think about it for a second. It's what's powering electric cars, the fan that's cooling you down, the trains that move millions of people. It's even the tiny little motor that makes your phone vibrate. And the incredible part is, it does all of this quietly and cleanly. No combustion needed.
Okay, now here's the thing that'll blow your mind. The basic idea behind the electric motor is so ridiculously simple, it almost feels like a cheat code for physics. So let's just break it down.
It all comes down to this two-step process right here. That's it. First, you run an electric current through a wire and poof, you create a magnetic field. Second, you use the forces of that magnet, the push and the pull, to create actual physical motion. That's the entire magic trick. And yeah, that's really it. At its heart, every single electric motor, from the one in a little toy car to the one in a massive high-speed train, works on this exact same principle. Electricity becomes a magnet, and that magnet makes things move. Simple as that. So the key ingredient here is the electromagnet. You just wrap a wire into a coil, shoot a current through it, and you've got yourself a magnet. But here's the best part. You can turn it on and off with a switch. Current on, you've got a magnet. Current off, it's just a piece of wire again. That simple control is everything. All right, so how do we get from a simple on-off magnet to something that spins continuously? Well, it all comes down to this really clever game of cat and mouse, what we're calling a magnetic chase. So inside every motor, you've basically got two main players. There's the stator, that's the outer ring that stays perfectly still. It's going to hold our electromagnets. And then inside that, you have the rotor, and that's the part we actually want to spin. The names really say it all. One stays, one rotates. So the whole goal, the entire game, is to use the electromagnets in the stator to constantly push and pull on the rotor, basically tricking it into spinning forever. You have to create a force that never ever lets that rotor rest. And here is the genius trick. By super quickly switching the electricity on and off in different coils all around the stator, we create a magnetic field that isn't just sitting there. We create a field that actually rotates. It's like a whirling, invisible force. Now, the rotor, which has its own magnets, is always trying to catch up to this moving magnetic field. It's desperate to align itself. But just when it gets close, boom, the field moves again. So the rotor is stuck in this state of perpetually chasing it. And that chase is the rotation. That's the whole secret. This endless pursuit of a moving magnetic field translates directly into the constant, smooth spinning motion that powers our entire world.
So we get how they work, but why are they such a game changer? Well, let's talk about efficiency, because this right here is where the electric motor just absolutely leaves the old internal combustion engine in the dust.
Just look at that number for a second. 90%. An electric motor can turn up to 90% of the electricity it gets into useful mechanical work. Think about that. There are no explosions, almost no heat waste, and very little friction. It is an unbelievably direct way to turn energy into movement.
I mean, when you put them side by side, it's not even a fair fight. A gas engine, it's lucky if it hits 35% efficiency. Most of that energy is just lost as waste heat. It has hundreds of moving parts. An electric motor has just a few, and its only real byproduct is motion itself. It is simply a more elegant and efficient machine.
So what does all this mean for us? It means the future is being built on the back of this simple, powerful machine. As we all try to move away from fossil fuels, the electric motor is stepping up to power, well, everything. And you really can see it everywhere once you start looking. I mean, from the obvious stuff like EVs and drones, to all the hidden motors in your washing machine, your computer's hard drive, elevators, fans. They are the quiet, unseen engines of modern life. Here's a great little rule of thumb for you. If a machine is doing work, but it's doing it quietly and without a puff of smoke, chances are you are looking at an electric motor. You're actually seeing a piece of our clean energy future in action.
So, the next time you feel your phone vibrate, or you watch a drone lift silently into the sky, just remember what's really going on. It's not magic. It's just electricity, using this elegant dance of magnetism,
pretending to be muscle. And wow, what powerful muscle it is.